Bismillah ar-Rahman ar-Rahim. On behalf of the WSTA Board of Directors and Scientific Committee, I would like to welcome you all to the WSTA 15th Gulf Water Conference. I would like to thank our host, KAHRAMAA, for their generous support for our speakers and for providing all these facilities. At the outset, I would like to acknowledge the outstanding efforts of the organizing committee, headed by our WSTA president and Ali Rida, and also the scientific committee, for all the work they have done in preparation for this conference. I would like especially to thank our knowledge partners and sponsors. And if the people in the back, if they can just put the presentation. Excuse me. Hello? Can you make the presentation? Just the first, yeah, just good. Okay. These are our knowledge partners. They have supported this conference. I would like to thank them, sincerely. We will be having a very rich conference in terms of topics and issues on 3 days. We will be having 20 keynotes and almost about 50 papers, 6 special sessions on special topics, MIS, Management Information Systems, Technology and Agricultural Water Management. The MIS will be provided by UNESCO Doha. Technology and Agricultural Water Management will be provided by FAO. Decarbonization of the water sector will be provided by the Secretariat General. We'll be having also a session especially on effectively managed utilities and demand management provided by ACWUA, our partners. We will be having also privatization and regulation of the water sector will be also by ACWUA. We are having also a session on special R&D and capacity building needs provided by UNESCO Cairo, and that's it. We will be having also 2 training workshops, one on wastewater treatment and reuse, provided by EMI, and the other one is going to be on sanitation safety plan tool, will provided by WHO SIHA, which is Rola. Thank you very much for all these contributions. I hope you benefit from these all activities the most, and participate actively by asking questions, networking, and sharing expertise. This is the first session. It's called Innovation and Water Management, Technological Innovation and Management. I will be giving a very brief presentation on the main issues that we face in the GCC, and then I'm going to give just a glimpse on the role of artificial intelligence in water resources management, and what are the main issues that we face in having AI being employed. Being employed in our water sector. So if I don't go wrong, I think I have to click on this. Okay. So to start with, I think we should start with what is the water scene in the GCC. GCC have experienced in the past 5 decades unprecedented socio-economic development. That's major transformation has happened to the countries, where we have rapid population growth, rapid urbanization, rapid water need as well. But this rapid escalated water demands goes beyond our limited natural water capacities. Despite this fact that we don't have enough, or we have limited natural water resources, we have done very well in providing the population with water supply, and of course that's by relying on desalination. However, desalination is expensive, and desalination has major environmental impacts as well. And it's also energy intensive. These are the major things. Our agricultural water demands are met by groundwater, overexploitation, and also another issue is that most of that groundwater is actually non-renewable. And that's again poses the question, what is our exit strategy? What we will be doing next after the depletion of that resource? We have also an issue of low rate of treated wastewater, despite the treatment of almost all our generated wastewater to the tertiary level. In most of the cases, almost 90% of our treated wastewater is being treated to the tertiary level. Despite this, we're still not using more than 35% of our treated wastewater. And that's also economically, it's called major lost opportunities. And finally, and I think everybody has seen this, we started to see a lot of an increase in the frequency of extreme events. It's an opportunity as well as a challenge. It's an opportunity if we can capture that water and store it and use it, but it's also a challenge because it has also the destructive nature embedded in that. This is the water scene. The water challenges in the GCC are being addressed for a long time from the supply side only. Whenever there is a need, we build more desalination plant, we do that and that, but I think recently we start to shift toward demand management and thinking about the other side of the coin by looking at that. Here, technology has played a major role, and it is still playing a major role. And these are, a trend going on in our water sector. Now, there is a new generation of emerging technologies driven by ICT, and so many things are changing around us. They are changing, transforming the whole entire systems of production and consumption and and management and governance, including the water sector. The water sector will not be left behind. It has to move also with all the sectors in this transformation to what we call a digitization of the whole world, which is the fourth industrial revolution, and we are actually on the brink of it. So these tools and these technologies, they provide us with a powerful enabling tools for effective water management. Okay, we can use them in our urban water management. We can use them in smart agriculture. There are so many applications. The sky is the limit for these, and it's just the limit is our imagination of using that. And we think that this theme that we have chosen is appropriate at this time of our maturity in terms of conferences, that we think that technology employment in the water sector is an important issue now. And you can see things are moving very fast. And we think it is very important to really shed light on this. That's why we have the scientific committee of the conference have selected the technology as a theme in the water sector. So our objective here actually is to review the current and emerging technologies used in the water sector or water subsectors and improve their awareness to the ship makers as well as us. Okay, identify their advantages, their challenges and constraints, and present technological solution to the water sector. That's the main issue of us. And I hope the whole discussion in this conference try to focus on how can we use and how can we employ these technologies in making and alleviating our challenges in this very arid region of the world. I have very, very quick presentation. It's not easy to talk about about emerging technologies, but I try to take only artificial intelligence and try to just shed light on it. and what are the main constraints that we are facing now in getting that into the water sector. So these are the emerging technologies that can be used for water resource management. We have artificial intelligence, and these are the applications. We have Internet of Things. We are having big data analytics. We have robotics. We have remote sensing. We have blockchains, and we have also at the end quantum, computing or technologies. All these, are being employed now in the water sector. Almost the water sector is adopting a lot of these technologies and you can see them here and there. It's like glimpses. They are not coming in the whole water sector, but you can see one country or one area, or for instance, Bahrain or Qatar or Saudi Arabia, they are doing this in this region. So it's not sweeping, but it is infiltrating slowly. I'm going to take only this, artificial intelligence, very quickly and tell you what are the main constraints as a case study, that why we are not moving very fast in that. And of course, artificial means a human, created, and intelligence means thinking power. Meaning that artificial intelligence, we are emulating human cognitive abilities in terms of learning from experience, adapting to changing context, and having cognitive abilities that make it, the machines will be able to take decisions for us. And I'm not sure if this is going to happen, but at least it will support us in this. Now, if we look at the AI application areas in water management, you will find that there is a lot of application. We are doing this as a research, but we are trying, with a postdoc we try to put all the potential or already implemented, application for AI from the supply side or demand side, and also from the whole process from monitoring, and prediction and controlling system. All these are the application. But we all agree that on the benefits, that there are so many benefits that we are having, which will be enhanced efficiency, improved accuracy, better preparedness for water scarcity, improved water environmental governance, and so on and so on. But when you look at the fishbone here, this is where really lies the problem is. We have 4 major issues that we have to tackle. The first one is the data. There's so many problems with the data. There are so many formats, so we have so many issues with that. The second one is the human factor. The human factor, where our people are not, able to communicate with the AI. And there are a lot of miscommunication. There is a lot of incapabilities. I am a water scientist. I'm not an AI scientist. So I need somebody to join me. We are having also the modeling barriers. Different languages and different output. And there's a black box. When I give the data to a machine and the machine comes up with a solution, I don't know what happened. How was the algorithm was used? It's a black box for me. So this is make me a little bit apprehending the process. And finally is the infrastructure. There are so many softwares and hardwares that we have to look at. These are the main issues that we are facing. I hope that in this conference we really discuss these issues a little bit in deep. We always use the Gartner hype cycle for any emerging technology, how it is going to be adopted in the society. And we think that we are now in a very, very early stage. It starts with the innovation trigger, and then it goes up with a lot of expectation, and then we go down. This is the end of the disillusionment, and then we start becoming mature. So I think we are now at the trough. Everybody is thinking that this is going to be solving our problems and it's going to make our life easy and so on. It is not. It's not going to substitute us. It is going to be there, but it's not going to substitute humans. It's going to continue spreading until it reaches a level of maturity that we think. How to take it from this stage to that stage is our work. It's our R&D. It's our application. It's our conviction that this thing, can help us in the future. And I hope this contribution, this conference can contribute to advancing our knowledge in terms of artificial intelligence and the other emerging technologies. So we are still in the area that we are still not reaching the maturity level of those. And hopefully by forwarding or guiding our research in that direction by sitting with people from artificial intelligence or from the ICT, sit together, water sector and the ICT together, sitting together and trying to find solution for our water sector will be the best solution. I'm not going to go back to school and learn about computer science. I am a water scientist and I need somebody from art. So this is like call for people to sit together and discuss this issue together, okay? Thank you very much. This is a very short introduction. I just wanted to set the stage for the meeting. We will be having now 5 prominent, renowned keynotes. We will be starting with Hammou Laamrani. He will be presenting his presentation will be on digitalization of the water sector. Hopefully he will be complementing this. I just give you a kickstart now for this. Let me just introduce Hammou until they bring your, if you can put Hammou's presentation, please. Hammou is the Economic Affairs Officer and the UN-ESCWA, and he's in charge of National Agenda for the Future of Syria Program, Agriculture and Livelihood, based in Lebanon. He used to work as a senior expert for the Water, Energy, Food and Climate Nexus for the League of Arab States. Before that, he was in GIZ, and before that, he was in the IDRC, the first project when I met him during that project. Hammou, the floor is yours. Please, you can take the floor, and you have this.
صباح الخير مرة ثانية وأجدد شكري للمنظمين على الدعوة. I would say that it's easy to talk on digitalization, but before Waleed, because what I would do is I would just concur with some of the statements he has made in detail. Digitalization is part of the solution. It's not going to be the magic solution to solve the water security issues in the Arab region. We should admit first that technology is about tools, and water security is making decisions which tools, by whom and when, and at what cost. I will give a brief presentation like my colleague and friend Waleed, on the context we know, and then what digitalization is promising, and think of what we need to consider in terms of pitfalls and payoffs of the digital transformation that is happening anyway in the water sector, like the rest of the sectors, by the way. And what countries are doing, selected examples from selected countries, and what support ESCWA can provide to countries and to research organizations, and they will end up with a few concluding remarks. This is the situation we want to change. We all know scarcity is growing, and the per capita share of water is decreasing, the resources are depleting, and they are likely to even diminish over time. So that's the reality we want to change. And we also know that the biggest challenge in the region is the paradox of agriculture, that is a large user of water resources, but it's not the most efficient so far. So those are the realities we need to think of when we think of digitalizations and what it can do for the region. So digitalization in the water sector should not be restricted to the discussion on urban water, because it's not the bulk of our use or the use of our resources. The situation is even going to be more challenging in the future, given the agreement of most of the models, and I'm sure that Vijay will elaborate on that. predict that the region is going to be facing more serious problems than the ones we are facing today. Digital technologies are developing fast in the region. And they are developing faster in the rest of the sectors. If you look into trade, into services, the development is faster. It's percolating slowly in the water sector and to a slower pace at the policy level. And if we look into the revisions that have been made to water strategies across the region, a few have integrated digitalization as part or as a component of their strategies. However, in overall figure is quite impressive. The use of online products and services has increased from almost 30% in 2012 to 70% in 2022. So as I said in the beginning, the digitalizations will happen anyway. How to benefit from it for water management, for water planning, for foresight of what water management will be in the future. A question that is not easy to answer. In 10 years' time, what would be water management about in the Arab region is something we need digital solutions to know as part of the instrument and tools. The economic driver of transition to digital economies in the GCC countries is quite significant. We're talking about more than 300 billion over the next decade. So bottom line, we are facing a difficult situation, in somehow a paradoxal situation where we need to be more efficient, more aware of the use we make of our resources, and the digitalization is going to be part of the solution, and it's growing in the region. Globally, it is considered as one of the major transitions that could accelerate the achievement of the SDGs in the 2030 agenda. And it's critical for the rest of the transitions. That's why it is an extremely relevant topic for our discussions over the next days. And I'm very happy that a lot of sessions are going to be focusing on this topic. Digitalization could contribute, as Waleed mentioned, to the solutions to the chronic challenges that water scarcity and water security are facing in the region. In terms of providing data, data is one of the big challenges in the region. We don't know much about a lot of things that we should know to plan properly and foresee the future. Data on groundwater, for instance, data on land use and its impact on water resources. So digitalization is going to be contributing to today's planning, but also to the foresight and the projections, useful in early warning and crisis management, and in making the water sector resilient and sustainable. It takes and it needs participation of people, and that's a governance issue that we need to discuss in depth. What kind of governance or effective governance is needed when you use digitalization as a strategic mean for planning water resources management, but also planning the projections of what water resources will be in the future. طبعا في challenges that are facing digitalization not only in the GCC countries but in all the region. A comment probably to start with is that the transition to digitalization in the Arabian region is not advancing at the same pace. A cluster of countries is the GCC countries that is moving fast, and the middle income, upper middle income are doing quite good, thinking of Egypt, Morocco, Jordan, Tunisia, and there are countries in conflict that are far behind. So there is a digital divide between the countries. That's number one challenge. Number two, there is a digital divide between cities and rural water, water in agriculture. Access to internet in rural Arab region is not comparable to urban. Given the difference in infrastructure, in access, in capacities, and that's a challenge, because if we think of changing the situation by acting on agricultural water use, then there is a gap that we need to bridge in planning the transition and accelerating the transition to digital tools implementation in the water sector. We have a skills problem. The ICT skills are oriented to business, but not attracted too much to water. So this is also a reflection to make. How could we attract more young entrepreneurs interested in doing business in innovation and digital solutions to be part of the water sector solution searching and supporting the decision makers in the water sector. Integration and interoperability of the systems is another challenge. And of course, the limited engagement of research and innovation. And that's why we have this team today. What could we do? We have the water research community in one hand, and those are water experts. And we have the digitalization experts on another hand. And those are not two communities that are designed to work together. So what do we need to make sure that innovators are connected to the water resource experts, and particularly in research and academia? We need to do more in education to make sure that we have the critical mass of educated people that could take up the challenge of grounding the digitalization technology in the Arab region, as I stated in my speech today. And to make sure that we have the pool of expertise built through education, higher education in particular. The innovation is also in the ICTs in general, and digitalization in particular is driven by the private sector. Government research institutions don't have the financial capacity they need to compete with private companies doing research and innovation on digital solutions. So how to make sure that the private sector is engaged, is committed, and working together with the public sector. Private sector has the advantage of being profit-driven. How to make digitalization of water sector profitable for the private business. بعدين في risk that is we need to think of as we plan for transition to digital solutions in the water sector. It's about cybersecurity risks, and it's becoming a reality. And it's no longer a luxury discussion. So unless you have a combination of your digitalization strategy and your cybersecurity strategy, then you are running into a risk. And the risk is very high because it's about drinking water. It's about water for agriculture. So how far are we in that? I think the GCC countries are doing quite good compared to the rest of the region, but it still has issues to be considered in terms of the technology itself, but in terms of the environment around cybersecurity. أول حاجة strategies for cybersecurity. So there are, luckily, some of the countries thinking of the Kingdom of Saudi Arabia, thinking of Emirates and Qatar, there are policy documents framing the issue of cybersecurity as a key one. Regulations and the regulation framework, compliance with the requirements and standards, and of course, collaboration between governments, agencies, the private sector, and academic institutions. Investments in cybersecurity should be parallel and equally important as the investment in digitalization. Otherwise, the investment is a high risk. 2 minutes? Yalla. I will skip that one. So what are we doing in ESCWA? Two things. One is we have a unit working on digitalization in the Arab world. It has worked hard over the last 10 years. And we now have a regional strategy for transition to digitalization. We have a framework to monitor that strategy. And we have a joint work with the League of Arab States to consider the needs and the priorities of the countries in the way we plan, the way we implement, and the way we report about what we implement. And we have a regional agenda that has been adopted last year. What countries are doing? There is a lot happening in digitalization in the water sector. I'm selecting a few examples here in terms of using the remote sensing and simple technologies for estimation of the ET in agriculture. I'm thinking also of the ERWI application as an example that IMI has developed and that is very useful. It instructs farmers on when and what amount of irrigation is needed for crops. So those are examples I cannot run through for the reason of time. Otherwise, something is happening in the countries, and some are strategic in their move in digitalization. حتى لن نستصغر ما تقوم به الدول يعني. ESCWA is developing platforms, digital platforms that provide data and information on groundwater with a platform available and accessible online. Also, on use of remote sensing to assess the groundwater used for irrigation, and a RICAR initiative that is providing data on climate with a focus on water, of course. And we have regional digital economy transition and vision in the region, which is an active network that we need to connect to at some stage as a water community for the sake of knowledge of what they do, but also for the sake of working together. I conclude with quickly. عندنا أربعة key drivers that are accelerating or that needs to be accelerated to accelerate the digitalization. بدنا innovation, بدنا capacities, وبدنا regulation, وبدنا investment. So the four elements where we need to put our thinking and our discussions over the coming days. طبعا digitalization and cyber security should go hand in hand in terms of planning, in terms of investment. And we need to mainstream digitalization. And I'm thinking of the example I had a discussion with Dr. Waleed recently. The unified water strategy of the GCC countries, that's a wonderful strategy and a teamwork that is setting the stage for what needs to be done من هنا لحد 2035. Also the Arab water strategy, 2030. So those are examples of documents that are guiding the regional action and where digitalization and cybersecurity should be prominent and mainstreamed. We need to invest more in research, and we need our whole of government and whole of society approach for the sake of making sure that everyone is contributing to benefit from the digitalization, but everyone is contributing to cybersecurity and risk mitigation. And finally, we need to accelerate the regional cooperation as a way to achieve all of that. بشكركم and thank you for your attention.
Thank you. Thanks, Hammou. Very interesting talk. Would like to, and Hammou has talked about a very important issue. That's it. That the AI is going faster than the decision-making process in the water sector. It's our job is really to get that on time. I'm trying to get the second speaker bio. Just a minute with me. Okay, got it. Good. Okay. Our next speaker is one of the luckiest people because he's from the water sector and also from the IT. So this is exactly what we are lacking here. It gives me pleasure to introduce to you Mohammad Rajabi. He came all the way from University of Luxembourg. He's a Marie Curie Fellow at that university. His research primarily concentrates on enhancing simulation tools for water resources management by integrating machine learning techniques. He specializes in neural network and physics-informed machine learning, focusing on their application to improve the accuracy, computational efficiency, and data integration capabilities of water-related simulation. Dr. Mohammad will be talking about deep neural network application in environmental and water resources simulation. Please, Mohammad, the floor is yours.
Bismillahirrahmanirrahim. Thank you so much for the introduction. Artificial intelligence and machine learning are buzzwords we hear a lot these days because they have become the key drivers of innovation in a wide range of areas, including environmental and water resources management. Machine learning includes a huge number of tools. Some of them have been around for many years now. But the tool that has made all the new achievements possible is deep neural networks. So this will be the focus of my presentation. I will discuss what they are and why they are particularly important in environmental and water resources simulations and management. I will talk about the diverse architectures used in this context and physics-informed neural networks in particular. And I will provide some prospects for future research. The target, the audience for my presentation is mostly people who are new to this subject, but are interested in applying them to their problems. But I hope it will be also useful for more experienced researchers seeking insights into future research opportunities. So I will mostly focus on predictive simulations because, you can do many things with these deep neural networks, but my focus is on simulations as a specific use case. By simulations, we mean a computational process that models the behavior and interaction of environmental and water resources systems in order to predict how they behave in different circumstances. And it has a very wide scope. It encompasses a wide range of topics, including hydraulic simulations, simulation of the spread of pollutants, sediment transport, water consumption patterns, air pollution modeling, etc. So the traditional tool for these is physics-based analytical or numerical models. So we have a wide range of physics-based models available for groundwater simulations, for rainfall runoff, for lake simulations, etc. This has been a tool that has been used widespread in the past at least 6 decades. But these physics-based numerical models have a number of well-known challenges. One of them is that they have a very high computational demand. So for applications that require real-time simulations or repeated simulations, like uncertainty analyzers, for example, the computational needs become problematic. Another key challenge is that for many processes, we don't still have perfect mathematical formulations to incorporate in physics-based models. And as a result, there's a discrepancy between what models predict and what actually happens in the field. So in response to these challenges, people have started using data-driven machine learning models that can learn from data without needing the physics, without needing mathematical formulations of the physics. The additional benefit these machine learning models provide is often faster simulation, less effort, and the fact that they can learn from data alone. There are many machine learning models available. Some of them have been around for at least 20 years now, like random forest, support vector machines, etc. And they are all mostly statistical methods that learn from data to predict unseen circumstances. So these have been available and used first in academia and then in practice since the late 1990s, and they are still widely used. The use cases include surrogate or meta modeling, where they replace physics-based models in computationally intensive tasks like uncertainty analysis. Another use case is where we don't have a mathematical formulation to describe a process. We use them to learn from data to make predictions. We use these machine learning models for inverse modeling, where we aim to estimate the parameters of the system from observations. And we can use them for feature extraction, meaning that we use them for identifying the key parameters governing a process. This can be an independent task by itself or as a precursor to simulations. These machine learning models, although they are very useful, they have their own set of challenges. The key challenges are difficulty in handling rare situations called black swans often. They struggle to adapt to scenarios not present in the training data, and providing training data is a major challenge as well. They are insufficient in managing large data sets that are becoming available using satellite imagery, drone imagery, etc. And they have a limited capability in uncovering deep, complex relationships. So this is where deep neural networks come into the picture. They offer greater flexibility, higher prediction, and they can handle large data sets. So this is the key tool that has become available in the past couple of years. So what are deep neural networks? They are a kind of neural network, meaning that they are computational models inspired by the human brain, composed of multiple layers of neurons that perform like a weighted sum of inputs plus some activation function that creates nonlinearity. So this is like a very brief mathematical description of these models. And they learn from data. They are presented with data, they learn the patterns in data, and can then make predictions on unseen circumstances. So what is the difference between neural networks and deep neural networks? Well, there is no clear line between these two. Deep neural networks are neural networks with more layers. That would be like a general explanation of them. But these additional layers provide a very useful feature, making deep neural networks global approximators, meaning that if you have enough data and a sufficiently large neural network, you can approximate any function. This has been proven mathematically. So why are these particularly beneficial in environmental and water resources simulations? The reason is that we deal with very complex systems. Natural systems are inherently complex, and there is often many layers of interactions between different parameters. And these deep neural networks have proven to be able to capture these complexities. They are also capable of handling big data, which is becoming available. I mean, in the past, we had little data. Now we have a lot of data, and the problem is becoming an analysis of this large amount of data that is becoming available. And deep neural networks are very useful in this sense. They are very powerful in feature extraction, in enhancing predictive performance, and they are adaptable to a large range of problems. So deep neural networks by themselves are not, just a single tool. They are a family of tools within the context of machine learning, and each having their own theory. And in the context of environmental and water resources research, people started using deep neural networks in their most basic architecture, meaning that they started using feed-forward neural networks. And we see a transition toward more advanced architectures, like convolutional neural networks and recurrent neural networks that have made spatial and temporal predictions more accurate. And there are a few emerging technologies here as well, including graph neural networks and generative adversarial neural networks that have made analysis of unstructured data, like point clouds that are generated using LiDAR data possible. And these architectures can be hybridized to do more innovative tasks. And they have found applications in almost every subfield of environmental and water resources simulations. Just as an example, we have used them in Qatar to predict the head change variations as a result of changes in recharge rates and based on the hydraulic conductivity distribution of the aquifer here. So you can do a lot of things with these. Another key trend that has become a key driver of innovation is the shift toward the use of field data, not just theoretical data, and also the incorporation of physics-informed neural networks. These are a very interesting topic in the context of machine learning because they come at the mid between physics-based model, numerical models we already used for several decades, and deep neural networks, which are a new tool. They come in the middle because they can learn from data, and they can also incorporate what is known from the physics. So they provide the added benefit of making the neural network predictions physically feasible. They enhance interpretability, meaning that you know what is happening inside the deep neural network, in contrast to data-driven neural networks, and they provide improved generalization. So at the expense of added, of course, computational demand, because they have to solve the physical equations as well, but they need less training data. So this creates a trade-off between the computational needs of simulations and computational needs of the training the physics-informed neural network. They are not a tool that can be used everywhere, of course. In order to use physics-informed neural networks, we need at least a basic understanding of the mathematical equations governing a system. And we need some data because they don't, I mean, they still require some data in order to be trained, and we need some computational resources, which are becoming increasingly available because now many organizations, many universities have access to high-performance computing facilities. So when I say physics-informed neural networks, the method is always, mostly, I should say, using physical equations as loss functions in neural networks. So everything remains the same. The same tools used in common machine learning tasks can be used, but with the added feature that physical information is used as additional loss functions, either as regularization term or an optimization function. And in the context of regularization-based optimization, they can be applied as soft or hard constraints. So here are some prospects for future research, which I believe that these will be the key drivers of both academic research and practical applications in the coming years. The first one is capturing multi-scale interactions, which is very hard using numerical models, and machine learning models are making this possible. For example, in the context of groundwater modeling, we have processes happening at the pore scale, we have processes happening at the core scale, and processes happening at the aquifer scale. So in order to model these at the same time, we can use machine learning models. They can provide scalability. And another key area of research is transfer learning, where we can train models using simpler problems and then extend them to more complicated tasks. And these machine learning models can be used then within the context of decision support systems to make decisions regarding water resources. Then there is the issue of multi-fidelity modeling, where we can use models of different scales of simplicity to simulate complex problems. And I believe these will be the key drivers of future research. Thank you so much for your time. Thank you.
Thank you, Mohammad. Our next speaker will be my dear friend Youssef Rosine from IWMI. He will take us back to our comfort zone a little bit, away from the artificial intelligence and machine learning. Youssef is the regional representative of IWMI, the International Water Management Institute for Middle East and North Africa. He has significant experience in sustainability stewardship and resilience building across the water and agricultural value chains in North Africa, West Africa, and Southern Europe, with multidimensional agribusiness corporations. He was previously a professor and researcher of the Mohammad Polytechnique University in Morocco, where he managed and contributed to the portfolio of research and innovative projects around climate change impacts and agro-hydrological systems, climate-smart water and crop system, as well as social and digital innovations for resilient and sustainable water and crop systems. He will be giving a talk on navigating water scarcity and supporting food security, market-based development for sustainable irrigation. Youssef, the floor is yours.
السلام عليكم. شكرا أخي دكتور وليد على التقديم اللطيف. أولا أود بطبيعة الحال شكر قطر قيادة شعبا ومؤسسات على حسن الضيافة وعلى احتضان المؤتمر، وكذلك أخص بالشكر الكهرماء وكذلك الأمانة العامة لمجلس دول الخليج، جامعة الخليج العربية، وجمعية علوم وتقنيات المياه بالخليج. بطبيعة الحال اللجنة العلمية وأخي البروفيسور Waleed Al-Zubari. So, as you can see, one of the key words of my presentation is irrigation. So we will talk irrigation today. And since the key focus of the conference is about technologies, so we will try to talk technologies in irrigation, but we will take it from a different perspective. So we know about the huge efforts in terms of innovation and bringing technologies to water management in general, including in irrigation. So, but today we'll try to look at how these technologies can be effective once brought, once implemented, once introduced. And one of the approaches that IWMI, in addition to other development agencies, are trying to promote is the market-based development approach or market system development approach. But before that, let me introduce quickly IWMI, the organization that I'm representing here today. So the International Water Management Institute, it is an international non-profit research for development organization. So our headquarters is in Sri Lanka, in the capital, Colombo, and we work in Africa and Asia through regional country offices. Our region is, actually we cover MENA, Middle East and North Africa region from our regional office in Cairo. And we are one of the CGR organizations. IWMI positions itself as a research for development institute supporting stakeholders, basically governments and other stakeholders in the water system, to tackle the water issues, water challenges in the interconnection between water and food, water and ecosystems, water and climate, and also water and growth, and also inclusion. So these are the areas where we try to bring science, research, to address these strategic questions. And obviously we try to adapt this agenda to the priorities of MENA countries. So now let's go to the topic of my presentation, and let's start from here, food security. So obviously MENA is one of the hotspots for climate change, water scarcity, so my colleagues did really explain this very well. So I will go to food security, and our region is also very special in regard to food security. These are the results of, or the indications of the World Bank. So we have a lot to do. Obviously, the region is very uneven. So we have different situations from country to country, or from even sub-region to sub-region. We have also some conflict-affected areas where food security is really problematic. But the good news is the situation is in the right way to be solved. And the issue is about to be sorted out according to the estimation of World Bank, but also other development institutes. So why? What's happened? Because of the stakeholders, mainly governments, believe in promoting agricultural activity, but basically irrigation, to solve the food security and food production in the region. Obviously, water will definitely help crops to cope with drought, and other challenges. So irrigation is important in this regard to increase in terms of productivity and also to make the cultivations resilient to climate change. So we have really brilliant, important initiatives, programs, plans in the region. So each country, and we are really happy as a research and development organization to see this kind of efforts of our governments and stakeholders in regard to development of irrigation to increase the food sovereignty and also to obviously enhance the livelihoods of farmers, etc. The other thing that amazes us, and also we are happy to learn that this trend is happening in our region in MENA. And I was also happy to hear the notes of His Excellency, the President of KAHRAMAA, about the work on demand. Because for a long time, the focus was mainly on the supply part. So we start also observing a kind of shifts in terms of focus on demand aspects. So working out the demand to make it more sustainable. So one of the things that we can do is to increase efficiency within the demand base. So how can we increase efficiency in the irrigation value chain? So we have a lot of steps, of milestones, checkpoints that we can act on to increase efficiency from the dam operations till the farm, or from the desalination plants or treatment plants till the farm and parcel. So we have a lot of checkpoints that we can act on. But today we will focus on the farm, and I will try to introduce the market system approach. And I will also introduce a study case from a country. It is not in GCC, but it is good to be observed from GCC in our perspective when it comes to irrigation. And this country is also observing GCC countries in terms of water development and digitalization in general. So to increase efficiency, we have a lot of technologies to use. I will not go into these technologies, so this is not really the scope of my presentation. But from our experience, and in some countries in MENA, but also in other parts of Africa and Asia, a lot of irrigation development programs have been implemented, and not all of them were successful at a certain extent. And these are some of the reasons why these programs were not really successful, mainly in making this technology that have been introduced viable, durable, even beyond the duration of the project. Inappropriate problem identification or partnership in the region or the country, inappropriate tools or mechanisms, lack of inclusivity or lack of accessible finance tools, and in some situations the parts of the irrigation system are not available once the program has finished. So these are some of the issues that make the development efforts in the irrigation value chain unsuccessful in some situation. And this is one of the examples in regard to the bad on the inappropriate identification of the problem to address through the introduction of the irrigation technologies. Like, for example, why the farmers are not using these technologies. For example, the very simplistic thinking can say because the farmers do not have enough information. But if we dig deeper in some situations, and I have another example in regard to finance. So if we dig deeper, we can find that the farmers are not using these technologies because they are kind of expensive. But why? Because the root cause of the problem is that the importers are under huge amounts of taxes, for example, customs fees, so which make the cost of these technologies high. So to address this problem, we have a lot of checkpoints again to tackle by improving the access of these water-saving technologies, WST, by working with the farmers or working with the retailers, working with the importers, or even working with the manufacturing ecosystem in the country to even have these technologies built in the in the country. So the market system development or market-based development approach work in this regard. So we look at the issue at a comprehensive way to understand the real cause of the issue, and also to be more inclusive in terms of action on the ground. So this is the concept. So we have three, let's say, groups. I will be very quick here. So we have the classic core functions, which are the relationship between the buyer and supplier, demand and supply, the very basic functions of any market. We have the supporting functions, which are functions that support by improving information and also any kind of support like extension service, any infrastructure, commercial marketing support. And we have the enabling functions, which are basically rules. So regular rules by the country, by the government, or in some situations, informal, cultural, social rules that can govern or that can affect the adoption of these technologies. So as you can see, this approach will help in having a system thinking of the issue, facilitating the exchange between all stakeholders, more inclusion, obviously, and adaptive management, because we can have a lot of iteration to make this sustainable and viable introduction of technologies in the field. So these are the steps. We activate demand first, then we work on the supply side, and then we go to the support function to activate the technical services, and then we work on the financial aspects of the market, and then the enabling environment in terms of rules that are informal or formal. So this is the example that I'm bringing to you today from the Kingdom of Jordan. So we had, as IWMI, had chance to implement the market-based development approach in many countries, including in Egypt. But today I'm bringing an example from WITS project, Water Innovation Technologies projects, where IWMI collaborated with USAID, Mercy Corp, and other partners to introduce technologies, but also practices, to increase the efficiency in the irrigation sector in Jordan. So Jordan, obviously, one of the areas where a lot of irrigation development programs happened. A lot of them are successful, obviously, but one of the enhancements remarks that we keep having is to make, as I say, these technologies or practices viable even beyond the duration of the project. I will not go into the water scarcity in Jordan. It is well known. So the project was 5 years project and with an objective of saving 18 million cubic meter per year at the end, starting of the fifth year of the project, by acting on different milestones of the irrigation value chain in Jordan, by using, obviously, the market system approach. So these are the 4 main areas of interventions that IWMI, in addition to the other partners, did by acting on information and providing enough knowledge in regard to the introduced technologies, by building capacity of all stakeholders, not only farmers, and also working with the finance institutions to keep providing financial solution even beyond the duration of the project, and also creating space for interaction and cross-learning between all the stakeholders and actors of the market. And these are the actors with who WITS collaborates. So you can see it's very diversified. So we've got government, we've got finance, we've got private sector in addition to farming communities, institutions. Two words about the results. So the good news is that we exceeded the initial objective of 18 million cubic meters saved per year, focusing on the farming sector, but the project also worked on the household sector. And these are the 3 key learnings from this project at the end, or let's say observations coming from this project after implementing the market system approach. So the motivations are very diversified. The economic one is really important. Saving money from saving water, but also saving energy from pumping is obviously one of the key drivers, in addition to saving enough water for other, let's say, crops, which can be and also need to be monitored for more sustainability. The expansion and response of the providers, technology providers, retailers, manufacturers, since the demand was created, so they had no markets to sustain. And they also invested in marketing and also after-sale support, which is very important in this field. And we, the colleagues, did really good job in demonstrating a really interesting return on investment which is important for the whole market, not only the farmers. So this is my last slide. Here I'm sharing some of our insights, not necessarily to conclude, but they can be also taken for reflection and replication elsewhere, including in GCC. So the water saving and irrigation efficiency technologies introduction need more dialogue, more cooperation. The importance of research and development is key here to understand. I mean, when we talk about research and development, not only in water, not only in biophysics, but also in the sciences of behavior, in the marketing sciences, in economic sciences. So a lot of areas where everyone can provide a part of the solution. And obviously, the water and energy nexus is important. We are happy to see this concept picking up. And it was demonstrated in this project because, as I said, one of the key drivers of the adoption of new technologies in this project was the economic aspect, saving money from the water saved, but also the energy saved from pumping. And we have evidences in this regard. Monitor and evaluation is also important in any irrigation development program, and obviously any quantity of water saved will definitely serve elsewhere. Development, growth, ecosystems preservation. So these are my key ideas, and thank you very much.
Thank you, Yusuf. Our next speaker will be Dr. Rola Al-Imam. Rola is working as the WASH Technical Officer at the WHO Eastern Mediterranean Regional Office, supporting 22 countries in the region. Rola has been working for more than 14 years on WASH, climate change, occupational health, and healthcare waste management. She holds an MPH from the Johns Hopkins Bloomberg School of Public Health in the US, and an MS in pharmaceutical health care from Long Island University, and a BSc in pharmacy from the University of Jordan. Rola will be addressing the audience on the topic of updated WHO guidelines and tools on water and sanitation. Rola, please.
Okay, so I will be shifting gears here and discussing and going towards health, since public health is our mandate at the World Health Organization. Hopefully, it's not going to be an uncomfortable zone for you, because we can all relate our work towards our own health. Okay. So I'll be talking a little bit about the WHO WASH strategy until 2025, and then what is the WHO role in WASH, what are some priority intervention areas in WASH, and what are the latest publications that have been launched by WHO on WASH, on water and sanitation particularly. So, safe access to WASH is essential to health. It's a basic human right and a component of effective policy for the protection of public health. So historically, WHO's work on WASH has been always to protect health in developing guidances and norms and standards towards protecting the health of human beings. And so WHO, since its inception in 1948, has consistently issued health-based guidelines and good practice publications on WASH to support countries in developing and setting their own standards and regulations, and in implementing good practices that have been being proved all over the region, and of course globally, on a global level. So the WHO vision for WASH is to substantially improve the health through the safe management of water, sanitation, and hygiene in all settings. So we're not only talking about the household level, but also at an institutional level, whether that would be schools and healthcare facilities, and we are looking forward to increasing the context of safe management of WASH. So the WHO WASH strategy until 2025 relies on main principles such as to prioritize actions with the highest public health benefit, to strengthen the health sector capacities in promoting safe WASH, and this is one of our main roles in strengthening the capacity of the public health sector and authorities towards their oversight role when dealing with WASH, and to employ the highest quality science. This is through collection, through the review and the use of data that is available in order to develop guidance and norms and for effective surveillance. So WHO assists countries in achieving SDGs, and this is, of course, through improving their policies, through improving governance and monitoring, towards achieving not only the WASH-focused SDG, which is SDG 6, as you very well know, but also towards other SDGs, such as SDG 3 on health and SDG 13 on climate change. So who are the key WHO partners? As we know, since it's a public health agency, so regularly we mean by member states mainly the national and local governments and authorities, such as the ministries of health, but also ministries that are relevant to water and sanitation. We also work with practitioners, with institutions for research and developments, through scientific advisory panels, expert panels, through academia, through research groups, and WHO collaborating centers. So I hope that we can work together towards protecting public health when working on WASH. We also work with some WASH sector partners, such as our UN sister agency, the UNICEF, and external support agencies such as the GIZ. So, as we said, WHO has a normative function, and it has a long-standing experience and history as a respected and an objective source of developing international guidelines and standards, the technical guidance on water quality management, sanitation and wastewater, and WASH policies and regulations. In addition, WHO has long been working on global WASH monitoring, and these as a increasingly reliable source of data and a comprehensive source of data to inform country policy decisions and WASH resources allocations, of course. WASH is the subject, of course, of the many WHA resolutions. So WHO, as a technical agency, does not only directly implement WASH infrastructure projects. Can I have some water, please? Yes? Okay, so we are a normative agency. And so, yes, thank you very much. Okay, thanks. Yes, exactly, so this should be safe. Okay, so we do not believe in WHO as that infrastructure is sufficient. It is actually insufficient, in our opinion, to attain sustainable and effective WASH or water service delivery or WASH service delivery in general. So this is why we focus more on developing normative guidelines in order to support countries through also tools and practical experiences to improve service delivery. So some of the priority intervention areas in WASH by WHO is the long-standing and the blue book, as we say, of the guidelines on drinking water quality, which relies on more than 60 years of guidance that has been provided by WHO on ensuring for the provision of safe water, drinking water to populations to ensure public health. And very recently, actually in February of this year, WHO has published the guidelines on drinking water quality for small drinking water supplies. And of course, the water safety plans, which most of you know about, which is a risk-based management approach for also ensuring safety of drinking water to the population. Also on sanitation, safety, and wastewater management, we have the sanitation and health guidelines that were published in 2018, and the sanitation safety planning approach that I will be talking later in a few slides. We also work on wash and healthcare facilities, including healthcare waste management and wash monitoring. And this is actually an important area of work that WHO performs, such as the WHO and UNICEF Joint Monitoring Program, the JMP, where actually it has been a source of information to many organizations and even to also research organizations on the coverage and the access to WASH globally and also in the region. And we also have the GLASS, which is the acronym for the Global Analysis and Assessment of Drinking Water and Sanitation. It actually monitors the enabling environment and governance, finance, monitoring of the WASH sector towards water, sanitation, and hygiene. And of course, integration of WASH with other health programs, such as climate change, such as nutrition, such as neglected tropical diseases. And of course, this is to increase impact and synergies amongst programs and other emerging WASH issues. So yeah, now talking about the WHO, UNICEF, JMP, this is taken from the progress report on WASH in households that was published last year. And our regional office has extracted information towards developing the regional snapshot of WASH in households in the region. As you see here, only 67% of the population in our region of 22 countries has access to safely managed water, and 55% have access to safely managed sanitation. Okay. I'm just giving here a glimpse of WASH in healthcare facilities that includes not only water, sanitation, and hygiene, but also healthcare waste management and cleaning. And this is taken from the 22 report. We have just finished and finalized with the countries consultation on the estimates of WASH in healthcare facilities globally and in the region towards the publication of the global report mid of this year, so in a couple of months' time. So stay tuned for that. Of course, here comes the recent publications by WHO. So there was the updated guidelines for drinking water quality that was published in 2022. These are the latest guidelines on drinking water quality that contains updates on some of the chemicals such as bentazone, manganese, as well as updates on cyanobacteria and other issues, like updated also chapters on climate change and emergencies. And also we have the guidelines for drinking water quality for small water supplies that I had just mentioned. So these are all to ensure the provision of safe drinking water for public health. The water safety planning, as mentioned by the WHO drinking water quality guidelines, is the most effective means of consistently ensuring the safety of drinking water supply to the public. And so it is a comprehensive and a proactive risk assessment and risk management tool and approach, a whole approach to ensure the safety of drinking water supply from the catchment to the consumer. So it's a proactive management approach from the source through treatment, distribution, and until it reaches the consumer at the household level. And so the WHO and the International Water Association have jointly updated the water safety plan and has published it last year in 2023. This is the second version of it to provide integration of climate resilience and equity of water provision to all. So the target audience are water suppliers, organizations supporting WSPs, and academic or research institutions. And as I mentioned from GLASS, where it has monitored, enabling environment of WASH, we can see from our GLASS reports that 2/3 of countries in the EMR have incorporated WSPs into their policies. Still, less than third of them where these WSPs are required in their policies, and still with that, implementation lags behind. This would probably explain why we only have 67%, less than a third of our population have no access to safely managed drinking water. So we might think about how to increase that. So as we said, it has to play a key role in delivering the safe drinking water. As per the WHO framework for safe drinking water provision, we have setting drinking water quality targets, health-based targets by regulators. Achieving these health-based targets by the water suppliers through the risk management approach of water safety plans, and verifying the achievement of these targets and effective WSPs through the surveillance agencies, which are the ministries of health. These are some additional resources on water. You can look at them later. These are the guidelines on sanitation and health to maximize the health impact of sanitation interventions. These were published by WHO recently, and towards summarizing the evidence on the links between sanitation and its impacts on health for provision of public health. It provides evidence-informed recommendations and offers guidance for action. These are the very long-standing 2006 guidelines on safe use of water, excreta, and grey water towards maximizing, again, the benefits of safe use towards health. Lastly, we talk about the sanitation safety planning. We will be having a training session on this approach and this tool. This provides a comprehensive and a step-by-step local risk assessment and management along the entire sanitation chain. It identifies and prioritizes the highest health risks along the sanitation chain to inform system improvements via a mix of control measures. And this second manual, compared to the first manual you see above it, it supports the recommendations that were presented in the WHO sanitation and health guidelines. And it's more simple. It includes climate risks because as a result of climate-related risks that are a result of water scarcity, sea level rise, and extreme weather events. So it also it's towards climate resilient sanitation systems. So you can go take the Open WHO course to learn more about the state of sanitation globally, the impacts on health, how can we accelerate progress, or you can go and dig deeper and dive deeper through videos, training, and additional resources on our Sanitation Safety Planning Learning Hub. So this is all for me now from WHO, and you can see more resources in the abstract summary. Thank you.
Thank you, Rola, for... By the way, there is a water here. Thank you, Rola, for the very informative lecture on WASH. And I would like also to attract your attention again for the training workshop that will be held by Rola, to this as a contribution to this conference tomorrow. On sanitation safety planning. We used to talk about water safety planning, and now we are moving to the sanitation safety planning. And it's a very good tool to make sure that it's a proactive. You don't wait for the thing to happen. You actually prevent them, from happening. And this is a very important approach instead of waiting and then dealing with the issue. Now, our last but not least speaker is from ICARDA, Dr. Vinay Nangia. Dr. Vinay is a principal scientist and research program leader for soil, water, and agronomy at ICARDA. He is a professor at Totori University in Japan and is also an adjunct professor at Texas A&M University in the US. He has a PhD degree in water resource management and 2 master's degrees. The first in biosystems and agricultural engineering, and the second in geographic information sciences, obtained from the University of Minnesota. His leadership and team building skills have helped solve complex challenges to water resource management posed by climate change. His work has been supported by about $35 million of grant support from various donors. He has published more than 300 publications, including over 100 peer-reviewed scientific journals and high-impact journals, and 40 book chapters and conference proceedings. Dr. Nangia is an advisory board member of GIWEH, a Geneva-based water think tank. Dr. Nanjia will be talking about a very important issue now, addressing climate change risks on water and food security in the Arab region. Dr. Nanjia, the floor is yours, please.
Okay, I brought my water security. Well, thank you so much for the introduction. And I won't take too long because I'm the last one in the session, and you all have been waiting patiently. So I'll be encapsulating mostly what the other keynote speakers have been touching upon and give you some applied examples of all these principles of water, energy, food nexus, trying to have diet, trying to save water, trying to see how you can have green energy solutions and those kinds. But just to set the scene, if you have been looking at the media, whether it's the TV channel or if it's a newspaper, you are increasingly hearing record-setting, floods, drought, extreme heat, all kinds of stuff. Everything is record-setting. And everybody is saying what you're seeing today was not expected to be seen for another 10, 20, 30 years. What we were expecting to see in 2030, 2040, 2050, it's happening now. All the climate change models that were predicting the future are starting to be proven wrong. The climate change is accelerating. It's happening at a much faster pace, and that's why all the assumptions that we have of how much time we have are proving to be wrong. And that's why it's becoming increasingly urgent, especially in this part of the world. We are facing today the climate change the rest of the world will face tomorrow. So if we can solve this problem, if we can mitigate this problem, if we can manage this problem in Arab world, in the dry areas today, the rest of the humanity farther away from us may be benefiting from the innovations and the cutting-edge technologies that can emerge out of this part of the world. What is happening here in this part of the region is that you have water scarcity, which is a physical water scarcity. The region is simply not blessed with enough water resources, and we have to live with it. We cannot just invest money to solve this problem. We have to accept that water scarcity is something we have to live with. At the same time, this is also exacerbated by climate change because the water demand, water supply is getting shifted. When we need water, it's not available. When we don't need water, too much is available. How do you bridge this water demand supply gap? And because of this, we are having problem of desertification. Almost we are losing 22 hectares of land per minute to desertification around the world, especially the dry areas. Because of that, we are losing biodiversity. If you look at our diets, it's so much wheat-based and meat-based, we have forgotten the indigenous foods that we used to eat long back. All this is compounding, leading to land degradation, unemployment, migration. Everything is compounded, but the bottom line is, the starting point is water scarcity and changing climate. That's where it starts, and it's a trickle-down effect, it's a chain reaction. Okay. Another thing that we have witnessed in recent times is that the areas that were typically classified as dry areas, where you have evapotranspiration exceeding the precipitation, evapotranspiration exceeding the available water resources, those areas are expanding. Some of the areas that were not known to be having the characteristics of drylands, you start seeing them with the changing climate. So these areas are expanding towards the Mediterranean Europe, to sub-Saharan Africa, to Southeast Asia. So it's becoming an increasingly bigger problem because until now it was just us facing it. Now the rest of the world is also looking to us to find the solution. So if we can create a drought-tolerant, heat-tolerant, salinity-tolerant variety that can serve the humanity today here, the rest of the world is interested in it because they will be needing in a few years' time. If you look at this ODI report that came out recently, it just shows you how dependent the region is on external sources, or how much is it importing for the sake of food security. Big countries like Egypt, like Morocco, like Saudi Arabia, are so food insecure at present. And as the climate changes, as water resources become increasingly diminished, this situation will only exacerbate with time. I used to live in Jordan for a while. Jordan is a country with the second most water scarce, if you look at the water scarcity indicators. Jordan produces enough food to feed itself for only 18 days a year. Rest all is imported. Similar is the situation with Qatar, with UAE, with other neighboring countries that are almost 90 to close to 100% dependent on imports, especially fragile economies that are extremely dependent on imports and don't have a lot of foreign exchange reserves. Even small inflationary pressure can cause lots of disruption, conflicts, unrest, youth unhappy, and it can easily trickle into a bigger problem. Now, if you look at this new report that has come out from FAO, it says, where are the drivers and triggers for transformation? Where can we find hope? And what are the overarching concerns? If you look at adopting technologies, if you talk about adopting digitalization, machine learning, how will it be an enabler and an equalizer and make it a flat playing field and not just benefit a few and not the others? So if you look at this, one of the things that we are saying is, will the global agri-food system sustainably nourish? The things that we are doing, are they sustainable in the long run, or we are just pumping lots of groundwater and putting lots of fertilizer and just thinking about the near term and not the long-term future? So is that sustainable or not? Secondly, looking at the socioeconomic side of things, the healthy diets, affordable healthy diets, is it going to be available only to the rich, or everybody will be having access to affordable, healthy diets that comprises food that is grown in a sustainable way? So not that we are just consuming lots of wheat or rice or maize, but we have a balanced diet at an affordable price. That is another area of concern going into the future. The third thing is that because of the digitalization, people have access to information. Is this going to be an enabler? Will citizens be informed and they will want to have balanced diet? Will they want to have nourishing diets? Will they want to change themselves, a behavioral change, moving away from meat, moving away from diets that consume a lot of fertilizer, use a lot of water, use a lot of land, and move to something that is locally produced and has a low environmental footprint? So will these triggers lead to a transformative process at the agri-food system level from the bottom up? This is another report that came out of that same series from FAO that talks about the alternative pathways to 2050. Where do they think the opportunities lie? Where are the places where we should be investing and paying attention to? First thing they talked about is sustainable agricultural intensification. What we talk about, more crop per drop. Without need for more land, without need for more water, how we can sustainably intensify these systems, how we can use our limited land and water resources and stretch them in such a way, all 365 days a year, we are trying to produce something that is healthy, that is nourishing, that is good for the environment and good for human consumption. Second is avoiding the land degradation. How we can, in areas, marginal areas like you find in this part of the world, how you can maintain some kind of vegetative cover to prevent desertification, to prevent wind erosion, dust storms, and health problems associated with land degradation. How can we prevent that? Third thing is using more water more efficiently, so adopting technology so that you bridge the water demand supply gap and use the water more efficiently. Trade-offs between agricultural yields and sustainability. Do you really want to maximize kilograms per hectare, or you want to stay within planetary boundaries and say, no, I don't want to reach the maximum. I want to stay a little below maximum so that it's sustainable. I'm not mining my nutrients. I'm not mining all my groundwater. I'm trying to leave something for the nature. I'm leaving something for the fisheries. I'm leaving something for the forest. So do I want to live in a sustainable manner, or do you really want to intensify these systems? And all this comes at a cost, at an investment. Why would someone want to adopt this? The bottom line is the farmer will adopt your solutions, your technologies, your recommendation, provided the benefits outweigh the cost. If the farmer is net more benefiting, more profitable by adopting drip irrigation, by adopting solar panels, then only he cares to have a conversation with you. So the bottom line is investment is important, but the farmer will adopt your solutions provided his benefits outweigh the cost of adoption. His top line, his bottom line should increase. Otherwise, just for sake of saving water, who cares? Because water is so cheap. So ICARDA is International Center for Agricultural Research in the Dry Areas. We are the CGIAR center, the only CGIAR center headquartered in the MENA region. We have been serving this region since 1977, and we have been doing it in partnership with many of you. So these are the places where we are situated. And I'm personally based in Morocco, in Rabat, but we have lots of colleagues in Egypt, in Central Asia, in India, and all over the world, trying to serve a territory from China to Morocco. We work in 4 different agri-food systems. We have the rain-fed agriculture, we have the irrigated agriculture, we have the agro-silvopastoral systems, and then we have the desert farming, which is something new that we are trying to get into. But these are the 4 distinct places that we're trying to solve solutions and find water-saving technologies for. I want to switch gears a little. Dr. Waleed just touched upon that there have been 4 revolutions in the world. In the field of agriculture, we have had 2 revolutions till now. The first revolution happened when mechanization was introduced. When mechanization was introduced, tractor came, land leveler came, planters came. A farmer could, because of the efficiency gains, produce enough food to feed about 26 people. Because of the efficiency gains. Then came the second revolution in agriculture, which was the green revolution. Because of intensification of irrigation system, the fertilizers and everything, the same farmer from same piece of land could produce enough food for 156 people. One farmer could, because of the efficiency gains, produce enough to feed 156 people. Now it's predicted that digitalization, the precision farming, the use of technology will be the next revolution in agriculture, and that will bring efficiency gains to the extent that the same farmer from same acreage of land will be able to produce enough food to feed as much as 265 people. So we are hoping that digitalization, and that's what's the theme of this conference, is embracing technological progress, could be the transformative change, could be the disruptor that could help us leap forward and solve this problem to a certain extent. So these are some of the things that we are trying to do for the smallholder farmers of the dry lands, especially the Arab part of the world. One of the things that we are trying to do is using technology, bring the power of decision makings in the hand of the farmers. So we are trying to introduce some handheld tools for extension agents from farmers to do an on-the-spot diagnostics. So for example, on the top left, I have a colleague taking picture with a thermal camera. He just takes a picture of with the camera. It looks at the temperature of the leaf. It looks at the temperature of the air. And the temperature difference tells you how water-stressed your crop is. So just taking a picture of your plant can tell you how much irrigation is required to be applied. The bottom left is a person taking picture using, taking a measurement using green seeker. It's just to measure the chlorophyll content. If the plant is not green enough, it tells you that the crop is nutrient stressed, how much fertilizer you need to apply. Then I have an NPK testing kit. On the spot, you can see how much is my soil property, how much is my crop requirement, and how much fertilizer I should apply. On the right side, I have an app that we have developed for the Egyptian extension agents. Just based on your GPS location, we can tell you what's the soil property, what's the weather forecast, which plant you should be planting, which variety you should be planting, when is the ideal time to fertilize, ideal time to irrigate, ideal time to do other management operations. So it's just based on your GPS location. It fetches all this information using modern tools. And we're trying to provide all this as open access, freely available, no cost involved, because we are an international organization that is here to serve the whole farming community of the world. This is another example where we are trying to use artificial intelligence, machine learning, and we are trying to tell the farmer, is your land even or uneven? Do you need to do land leveling because you have problem of waterlogging? We look at weather forecast, and we tell you in coming days if you need to apply irrigation. We look at the weather analytics and tell you if there is a probability of a disease outbreak. And these are all happening using these smart tools that we have introduced in different parts of the world. So the way it works is, smart irrigation is based on weather forecasting, evapotranspiration, using crop models to see how much water are you losing, what's the weather forecast telling you, and how much irrigation to apply. Smart detection are artificial intelligence-based motion-activated cameras that take picture of the insect, using digital library, identify the insect, count the population of the insect, and tell you exactly the disease this insect may cause and what are the remedial actions you can take to prevent that pest outbreak. Smart fertilization, like I said, is based on the NPK of the soil, NPK of the crop, and it tells you how much fertilizer to apply, which stage of the growth, so that you're not over or under applying and it's in the right proportions. Smart sensing is another thing. We look at the regression models, how much is humidity, how much is temperature, and we can tell you with very high probability that there is a probability of a disease outbreak, fungal disease, locust kind of disease, any kind of disease, just looking at the weather analytics. All this is helping solve the problems of the farmer because we are giving near real-time, in local language, easy to understand advisories. Not technical jargon. We are actually sending single sentence messages. And the other flip side of things is that the farmer can take a picture and send it to a scientist and say, I saw this yellowness on my leaf. I saw this waterlogging on the soil. I saw some white thing on the ground. What is it? And the farmer can also send an on-demand reply. So it's a two-way communication that we are offering to the farmer in a real-time basis. Other thing that we are trying to move towards is the carbon farming practice. Some of the things that our farmers are already doing, they don't even know that they qualify for carbon credits. So some of the things that our farmers are already practicing, for example, in Morocco, farmers are being introduced the conservation agriculture, the no-till planting, where you leave the residue cover on the ground so that you prevent some residual moisture from escaping. And that has stabilized the yields, especially in dry years. It has increased the yields. So no-till farming, leaving residue behind, having a cover crop, cereal legume rotation. Instead of having wheat after wheat after wheat growing, how about wheat followed by lentil or fava bean or chickpea or something, so that you rest the soil. You let the biological nitrogen fixation happen, and you improve the soil health quality. Adding organic matter such as biochar and compost. We are trying this in Egypt in partnership with Ministry of Agriculture. And at the same time, the last thing I'll touch upon in my next slide, but we have a network of eddy covariance flux towers. Oops, how to go back? Okay. But we are trying to say that it's not just more food. You have to think about environment. You have to think about your soil health. You have to think about your health, your human health, and how this concept of one health, where human beings, the nature, everything try to coexist so that you're not trying to harvest everything just for human being. The water, the soil, the carbon, everything, how you can live in harmony. That's why the carbon aspect of agriculture has become really important, especially for fossil fuel producing countries. If you can buy carbon credits by investing in agriculture in places like Sahel countries or in Morocco or in Tunisia or in Algeria or elsewhere, it's a win-win for all. Now, green energy solutions. That's the other thing that I think one of the speakers, maybe Yusuf, touched upon, is not just looking at water footprint, energy footprint of agriculture also. Especially in this part of the world, we get so many days of sunshine, how we can use that to our advantage. Some of the things that we are trying are like, for example, the agrovoltaic system, where we have solar panels at about 3 or 4 meter height. We produce electricity. So the times that farmer is not harvesting crop, farmer is harvesting energy, and he's selling that energy. Yep, that's one solution. The other is, instead of reverse osmosis, in partnership with MIT, we are introducing what we call photovoltaic electrodialysis-based desalination. The electrodialysis-based desalination, the advantage is that it produces significantly less brine, and it requires significantly less energy. So when you can solve that problem, you can have solar power doing desalination for you for brackish groundwater. Most of the farmers live inland. They don't live on the coast. They have brackish groundwater problem. So if you can use solar energy to clean this brackish groundwater, you can have the solution available as additional source of water. You're not just trying to solve the water use, the water demand. You're also trying to produce new water here. Third thing is solar-powered ultra-low energy drip irrigation system. Again, in partnership with USAID and MIT, we have tried to introduce a new kind of drip irrigation that operates at 85% lower pressure. When you need 85% lower pressure, you need a very small size pump, which can run maybe on 2, 3 solar panels instead of 8, 10, 16 solar panels. We have tried this with citrus, with olives, with date palm, with fruits and vegetables, and the results have shown that ultra-low energy drip irrigation has performance similar, has performance indicators similar to the conventional drippers in terms of clogging, uniformity, efficiency, etc. I'll skip this because I just touched upon the MIT drippers. This is an example of a innovation we have done in partnership with FAO regional office in the NINA region. We have a network of eddy covariance flux towers, evapotranspiration measurement instruments placed in different countries. And at every 30-minute interval, we provide data of actual measured evapotranspiration from various different places. So this is an open access dashboard. Instead of using the FAO KC values, instead of using the FAO evapotranspiration values, you have actual measured data available from the region through this open access database and a dashboard. We have these located in different countries, and soon we will be expanding it to 10 countries. Just recently, we have installed one flux tower in Dubai, another one in Saudi Arabia for date palm. Date palm was missing. Now we have added that. So this is another international public good, which is available for remote sensing, which is available for crop modeling, which is available for any kind of application, smartphone application that anybody wants to build. This is my last slide before I conclude, is that we are telling people, don't just think about maximizing the kilogram, but also try to see how you can diversify what you're trying to go. So trying to produce something like a plant-based protein, trying to grow something that is highly profitable, and it's not just marginal barley or wheat all the time. So this is an example on the bottom left. For example, a farmer in Morocco, if he just produces wheat after wheat after wheat, he earns about $800 a hectare. If he starts producing lentils, he earns about $630 a hectare. But through intercropping, through relay cropping, if he starts growing something between wheat, between lentils, you can see that lentil with beans intercropped can produce $1,200 a hectare, lentils with chickpea, $1,300 a hectare, lentil with quinoa, $10,700 a hectare, lentils with onions, $11,000 a hectare. Same land, same water, but by intercropping, by intensifying these systems, you are adding to the farmer's profitability. You are trying to introduce a crop that is very short duration, 60, 70, 75-day crop, and you can have additional source of income without need for extra land, extra water. So sustainable, profitable diversification of cropping system in this part of the world could be another game changer. This is my last slide. So, what's that? No, this is the concluding slide. It really says that. This is the real one, yeah? So firstly, climate change is something we have to adopt and we have to live with, yeah? There is no going back on some of the changes that climate change has done. The second thing is the drylands, the region is simply not blessed with water. It's physically water scarce, and we have to know that technology investment can solve this problem only to a certain degree, not completely. Thirdly, digitalization could be a transformative change. The typical age of an Arab youth is about 25. The typical age of an Arab farmer is 60. Farmer is aging. We need technology. We need to bring efficiency gains. We need to make it attractive for the youth. So IoT devices, smartphone applications, Uber kind of applications for farm machinery, all things could be a disruptor. And finally, CGIAR, we all, like ICARDA, IMI, IFRI, we all are trying to join hands to come up with consolidated bundle of solution so that you don't have to talk to us separately. We all come to you together as a package and try to offer our services. So hopefully that could also be a game changer for you. So thank you so much. These are just our sponsors and collaborators, and thank you.
Thank you, Vinay. We had a very rich multidisciplinary session. We started to understand and be familiar with the vocabulary of the digital revolution slowly with this name. We had Hammou talking about digitalization of water sector, and he emphasized the constraints that we need, that's constraining our move to a digital water sector, and that the need to move fast. We had Mohammad. He talked about the application of AI in water source management and the simulation potential, or unlocking the potential of simulation to support our decision making. Yusuf, he talked about on how to apply system thinking in solving the problems in the agricultural water management. We had Rola, who provided us with the guidelines and the tools available to us in water management from a quality and health point of view. And finally, we had Vinay, who addressed the issue of climate change and its impact on water, and he provided us with a lot of tools, of artificial intelligence tools. Thank you very much for this session. We are late by 15 minutes from the schedule. I think we have to close now, so we can have time for the short prayer and refreshment break, and then we come back at probably another after half an hour. Before we close, I would like to invite Dr. Mohammad Falah Rashidi to honor our speakers and present them with what they call the conference plaques. So, Mohammad, can you come, please? We have the things. I will call them one by one. You just. Okay. Cool. Wait a minute. 1, 2, 3, 5, huh? Okay. Dr. Hammou, Laamrani from ISCWA. Hammou, you have now two. Hammou, you have two. Mohammad Rajabi. Okay. Dr. Mohammad Rajabi. Dr. Yusuf Borzain. Dr. Rola Al-Imam, WHO. And finally, Dr. Vinay. Thank you very much. Now it is 12:15. We will have very short break for half an hour, prayer and refreshment, and then we'll come back for the first session. We will be having the UNESCO Doha office will be having a session on management information systems for efficient integrated water resource management. Then this will be followed by the FAO, R&E, session on technology to bridge the data gap for efficient management of agricultural water. And then finally, we'll have the Secretariat General of the GCC holding a session on decarbonization pathways in the water sector in the GCC countries. So please have a short break and do the prayer, and then we'll come back.